The final part of objective 1, remember objective 1 was taking the square root of perfect squares, negative numbers, and non-perfect squares. So we've already done a video on perfect squares and non-perfect squares, and I'm going to talk now in this video about taking the square root of negative numbers. So, if you take the square root of a negative number, the solutions are what's called imaginary. And I'm going to explain why they're called imaginary as I talk through example 1. So if you look at example 1, one big thing, if I was going to do this and try to simplify or solve this radical, is that there is a negative on the inside of the radical. Before these examples we've been doing before, there have been no negative. Like if you look at 32, there's no negative there, there's no negative here. But there is a negative inside the radical. Now, in this case then, hopefully you know that. Let's look at the positive version of 16. The square root of 16 is a plus and a minus 4. Meaning that 4 squared equals 16. And negative 4 squared also equal 16. If you take the square root of a negative, you can even try it on your calculator. Technically, this number does not exist. There is no number that if you were to square it, that would give you a negative 16. I just did both examples right here. 4 squared is positive 16, and negative 4 squared is also positive 16. So, mathematicians, when this was first discovered, had to come up with its own term, or its own space of numbers, I guess you could call it as well, for this situation when this occurs. And that's why they're called imaginary. And so imaginary numbers are distinguished with the letter I. Pretty simple there. And so how you treat them just as a positive number. You would take the square root. If it's a perfect square, then take it just as you would take the square root of a positive perfect square. But at the end of your answer, you have to distinguish that you know that you've entered into the realm of imaginary numbers with that letter I. So if I was going to do this, I know that the square root of 16 is positive or plus and minus 4. So I know that the square root of negative 16 has to be plus or minus 4. But I need to distinguish that we're entering into the realm of imaginary numbers because there's no number, like I just said over here, there's no number that when multiplied by itself, because technically what these are, again, are 4 times 4 equals 16. And then down here, it's negative 4 times negative 4, which also equals positive 16. There's no number plus positive or negative version of a number that would give me the original number that I took the square root of. That's why I need that I. So when you take the square root of a negative number, please, please, please always put an I, because that tells me that you know that you're entering into the realm of imaginary numbers. Now that number 1 was an example of a perfect square with a negative. So pretty easy. You just take the square root of a perfect square, it gives you your answers. Now number 2 is not a perfect square. If you take the square root, because again, I treat it originally as the positive version. Just check it on your calculator. The square root of 54 is 7.348. The decimal goes on forever. So technically, 54 is irrational and imaginary. Negative 54. So in this case, I would have to break it down just like I did in these examples, using my factor tree. So, numbers that go into 54. Again, 54 is even, so you could use 2, but try to use bigger numbers than that. 54 has factors of 9. 9 times 6 is 54. 54 divided by 9 is 6. Don't worry about this negative again till the end. Remember, a negative just distinguishes that you need to use an I. So I can continue to break these down to prime factorization. 9 breaks down into 3 and 3, and 6 breaks down into 3 and 2. Okay, so at this point, remember, you have to do this factor tree before I can answer any questions, so I need to see you making this effort here. At this point, when it's all the way factored, these 3's, this 3, this 3, these numbers can't be broken down anymore. Then I look for pairs. So I see a pair of 3's here, and a 3 and 2 are not pairs. These are lone numbers here. So I know that this pair of 3's is going to come out as just the 3 itself, and what's going to be trapped into the radical again. Two ways you can think about this. There's going to be a 3 left in there, and then whenever there's numbers either outside the radical that are together or inside the radical that are together, you multiply them. So to finalize this, it would be 3 radical, and 3 times 2 is 6. Another way to think of it, though, is that these two numbers didn't have a partner, so you just take the pathway back to the number they came from, and that would go inside the radical at that point. Same thought process. And don't forget, you need two things. So the correct notation of this is I comes out of the radical, meaning that this negative, in order to free it from the radical, you need to turn it into an I, and the I becomes outside of the radical. And what's left inside are all the things that couldn't be freed. So in this case, 6. And don't forget your plus and minus. You still need to distinguish that there are two answers now that satisfy this original radical, but you've entered into the realm of imaginary numbers because you took the square root of a negative. And in order to free this negative from inside the radical, to have it come outside the radical, you need to put the I outside the radical. That is my final answer.